So I get a lot of email spam, which makes me sad. And so what I would like to be able to do is to predict whether an email is spam or ham. And ham is just another way of saying not spam. And if I could do this very accurately, then what I could do is just automatically delete all the emails that are predicted as being spam so that I don't have to manually read through them and delete them. So how do I go about doing this? Well, there are many classification methods out there for classifying whether an email is spam or ham. One such way for doing this is called the naive Bayes classifier. And this classifier, like many other classifiers, works in two phases. There's a training phase, which is basically we learn a model from a bunch of emails for which we already know whether they're spam or ham. And then there's a prediction phase where using the model we've learned, we now predict for an email we've never seen before whether it is spam or ham. Okay? So let's talk about the training phase. In particular, we have some training data and emails where for the ith email, we have a label for the email. So this is either spam or ham. We also extract J features. So that will be given by these Y's. So for simplicity, in this video, I'm going to assume that we have a dictionary of J words, and Y for email I of J is just whether word J in the dictionary is present in email I. So basically these take on values of either 0 or 1. You could use much fancier features, and the features themselves, they don't need to be binary. They could be, for example, real valued or vector valued, or even non-numerical valued. But for simplicity, we're just going to assume this setup for our training data. I haven't given a model for this data, though, and for the naive Bayes classifier, the model is given by a hypothetical way of generating new emails. Okay? Let me make that explicit by saying what that generative process is. So the generative process for naive Bayes. So the first thing we're going to do when we generate a new email is we're going to say whether it is spam or ham. So the first thing is we're going to set the label C to be spam with probability S and ham with probability 1 minus S. So you can think of this as you have some biased coin with probability of heads S. You flip the coin. If it's heads, you set C equal to spam. If the coin says tails, you set C equals ham. Alright? So you randomly set the label C, and then what you do is for each of your features, so in our case for each of the words in the dictionary 1 up to J, now we're going to set whether word J is present. And this is going to depend on the label C. So if C is ham, then we're going to set Yj, whether the jth word is present, to be 1 with probability Pj, and 0 with probability 1 minus Pj. Instead, if C is spam, then we'll set Yj to be equal to 1 with probability Qj, and 0 with probability 1 minus Qj. And so, very importantly, Pj does not have to equal Qj. So this is important because what we're saying is that depending on whether the email is spam or ham, how likely a word is to occur is different across spam and ham. So, for example, if you see a word like Viagra, then it's probably more likely that the label is spam rather than ham. Alright, so this is the full generative process. It has a corresponding graphical model, which is as follows. We first generated C, and then we generated each of these features, Y1, Y2, up to Yj. And a very big assumption for the naive Bayes model is that Yi's are independent given C, the labels. And so even though the model makes this very big assumption, and this assumption you can see because if you condition on C, then you delete node C and all the Y's become disconnected. But even though we have this assumption, it isn't actually true for email, for example, because you can imagine that for email, certain words are more likely to co-occur, and thus they're not actually independent. the model just doesn't model that. And another thing is this model doesn't actually, for example, account for the ordering of the words. But that's okay. As statistician George Box has said, all models are wrong, but some are useful. And certainly the naive Bayes model is very useful. So in the next two videos, I'm going to talk about training and prediction. And specifically, as a preview, we don't actually know what these PJs and QJs are. So these we're going to have to learn. And in general, these are model parameters. And unless we have some deep insight for how to set these manually by hand, we're going to have to learn it from data. So that's going to be training. And then I'll talk in a different video about prediction. So assuming that you've fixed choices for PJs and QJs, how do you predict whether for a new email it is spam or ham?